Hello out there, welcome once again to my channel. Thank you for joining me in this lesson once again. In this lesson I'll be working on types of matrices. I'll be showing you about 9 types of matrices. The first is the row matrix, the second is the column matrix, the third the square matrix, the fourth will be the triangular matrix, the fifth will be the symmetric matrix, then the sixth will be the skew-symmetric matrix, seventh will be the scalar matrix, eighth will be the unit matrix, and the last will be the null matrix. To start with, I would like you to go through my introductory lesson on matrix. Introduction to matrices. The link is in the description. Please, I would like you to watch that if you haven't. Straight up, let's go to the first type of matrix, which is the row matrix. In the row matrix, a matrix with only one row is a row matrix or a row vector. A matrix with just only one row, as in this example where we have 4 3 2. 4 3 2 is a 1 by 3 row matrix. And remember, in the previous lesson I said the first number, when it's written in this form, this one stands for the number of rows, while this stands for the number of column. So here we have one row, 4 3 2, and we have 3 column. So this is a row matrix. The second is the column matrix. The column matrix is a matrix with only one column, and is also known as a column vector. An example is this we have here. We have a 8 3 6. 8 3 6 is a 3 by 1 column vector, 3 by 1 column matrix, or a vector, a column vector. 1 2 3, that's 3 rows, then a single column matrix. The third is the square matrix. The square matrix is a matrix in which the number of rows equals the number of columns, and is known as a square matrix. A matrix in which the number of rows equals the number of columns is a square matrix. In this example, we have 1 2 in the first row, we have -5 3 in the second row, and we also have 1 -5 in the first column and 2 3 in the second column. So this makes this a 2 by 2 square matrix, more like a square. So because it has the same number of rows and the same numbers of column. So we also have another one here. We have 6, we have 3, we have 0, we have -2 1 2 4 -1 1, and this is having 3 rows. Row 1 6 3 0, row 2 -2 1 2, row 3 is 4 -1 1. Is a 3 by 3 square matrix. So that's a square matrix. More often we work with this square matrix. So the fourth type of matrix I'm going to be showing you is the triangular matrix. And we have, if the elements of a matrix above or below the principal diagonal are all 0, the matrix is called a triangular matrix. As in this example, this A11, A22, A33 is the principal diagonal. This is the principal diagonal. This is the principal diagonal. So if the elements here, if the elements here, A1, 2, A1, 3, A2, 3 are all 0 or below, as in this case, if they are all 0, you see it forms something like a triangle. So we can call that a triangular matrix. So the focus is on the principal diagonal above or below it. If the elements are 0, then we can call it a triangular matrix. And this first example is an upper triangular matrix. Why? Because the elements below it are all 0. So down here we have a lower triangular 3 by 3 matrix, and as you can see, the principal diagonal is this, and the elements above the principal diagonal are all 0. So this makes this a lower triangular 3 by 3 matrix. I can also draw a triangle this way, and that's why it's called a triangular matrix. Then going on, we have the fifth one. The fifth one is a symmetric matrix. But before I show you the symmetric matrix, I'm going to tell you or show you what a transpose of a matrix is. Though I'm going to make a separate video for transpose of a matrix because of its importance. So transpose of a matrix, in a matrix, if we interchange rows for columns and columns for rows, we have a transpose of a matrix. Transpose of a matrix, if we interchange the columns for rows and the rows also for columns, we are going to have a transpose of a matrix. So having known what a transpose of a matrix is, we can go straight up to a symmetric matrix. So for a symmetric matrix, is a matrix which is equal to its transpose. Is a matrix, a symmetric matrix is a matrix that is equal to its transpose. And as I said before now, that when the rows change to columns and columns change to row, we have the transpose of that matrix. So let's look at matrix B here. Matrix B is a 2 by 2 square matrix and is having 1, minus 1, 2 rows, 2 columns. And as you can see here, 1 minus 1 has been changed, to 1 minus 1 here. So the rows here have been changed to the column here, the column here has been changed to rows, and the column here also has been changed to rows down here. So, and if you also see it as the rows, you see that it has also changed to column here. So that is a symmetric matrix. So as you can see that what is inside element B, matrix B is also what is in matrix B transpose. So we can say that matrix B itself is a symmetric matrix. So let's go to the next one. The next one also has to do with transpose. The sixth type of matrix is the skew-symmetric matrix. And if the transpose of a matrix equals its negative, if the transpose of a given matrix equals its negative, that is, transpose of B or B transpose is equals to negative B, then the matrix B is a skew-symmetric matrix. So let's look at the example to understand what skew-symmetric matrix is all about. We have B equals to 0, 1, minus 1, 0, and the transpose is the rows return to colon, and that's 0, 1 here, 0, 1 here. Then so this is the transpose, and as you can see that transpose of B is there is a minus. Okay, the minus is supposed to be out here, it's supposed to be this way. Okay, while I clean this bracket here. So as you can see that B transpose is 0, negative 1, 1, 0, and the minus can be factored out, so that makes whatsoever is inside the bracket to be B as given earlier. So we can say that the transpose of B is equals to the negative of the given matrix B. So that means B is a 2 by 2 skew-symmetric matrix. Let's look at the 3 by 3 square matrix. A is given as this, then the transpose is this. Then we can also see that minus is being factored out, and the element inside this bracket is A. So this is negative A, which is the transpose of A. Therefore, the transpose of A is equals to the negative of the given matrix A. Then we can say A is a 3 by 3 skew matrix. So that's the sixth. Then the seventh is the scalar matrix. Scalar matrix, scalar a number. Okay, it's a square matrix in which the elements along the principal diagonal are all equal and not equals to 0, while other entries are 0. So once again, we focus on the principal diagonal. When the principal diagonal, the elements in the principal diagonal are all equal, and every other entries are 0, as in this 0 here is 0 here. So we can see this is a 2 by 2 scalar matrix. Then another one, matrix Y. We have the principal diagonal, which is here. Then all other entries are 0, while the principal diagonal is not 0 itself. So this is a 3 by 3 scalar matrix. We go to the 8th type. The 8th type, here we have the unit matrix. The unit matrix, of course, you know, unit is 1. So it is a scalar matrix in which the entries along the principal diagonal are all equal to 1. So let me at this point say the principal diagonal can be this way, and it can also be this way. It can be this way also. So it's not always this way down. Okay, so matrix P is a 2 by 2 unit matrix because the elements on the principal or along the principal diagonal are all equal to 1. Same thing for matrix Q. Matrix Q, the entries apart from the principal diagonal are equal, they are 1, and all other entries are 0. So this is a 3 by 3 unit matrix. So I will at this point say the difference between a scalar matrix and a unit matrix is that for a unit matrix, the principal diagonal, the element on along the principal diagonal is 1, while for a scalar matrix is any other number apart from 1, but not 0. Okay, so then I go to the last one. The last one is the null matrix. It's a matrix in which every element is 0. It is also called the zero matrix. And an example, we have two examples here. This is a 2 by 2 null matrix, and this is a 2 by 3 null matrix. Thank you for watching. Thank you. I hope you enjoy the lesson. I will work on more topics, more subtopics on matrix. I'm going to do addition and subtraction, matrix multiplication, transpose of a matrix, power of a matrix, before I get into determinant and Cramer's rule. Thank you for watching. Please, I would like you to subscribe and share the video. Thank you.